It's like research.
Mm-hmm. Yep, absolutely.
I find out why people are using this and that.
Absolutely. You're taking a whole lot of data and you're crunching a whole lot of data to find a pattern. And what you're looking for is you're looking for that exact thing right there. You're looking for that linear relationship that exists. You're trying to find, is there a linear relationship between this data? That's the key. Okay? Regression is also the name of a movie that was released last year with Emma Watson, which is probably one of the worst movies ever made. Ethan Hawke. Okay? Ethan Hawke, I won't give it away, but he's a detective, and as he's investigating the crimes, he finds a pattern. So yeah, Ethan Hawke, Emma Watson, put it on your list to see on Netflix there. Regression. Okay. For this project that you're doing, remember, you must have one dependent variable. Don't go off the chart and say, well, I think this causes this and this and this and this and this. You cannot use regression for that. Regression is a very simple tool which looks at one dependent variable and multiple independent variables. So you're looking for the relationship between those and what is happening on that one dependent variable. Here, what we're saying is when you change price, what happens to quantity? Quantity is the dependent variable. Price is an independent variable. All you're doing is trying to figure this out, but you're doing more than price. You're adding a few more things in. You have to have at least 3 independents. So 3 independents that are causing changes in this dependent. In the examples we've been talking about, you can think of things like that microwave oven, and you can say what would cause the change in the quantity demanded of that microwave oven. Well, it's energy savings, it's the price of the gas ovens, it's the price of the food that you fix in it. You could come up with 3 variables real easily that you could tie into that and say these 3 things cause the change in the quantity demanded for that microwave oven. So that's the same thing we're looking at here. Okay? You can have, among your 3, no more than 1 dummy variable. That's it. Regression takes them, but it doesn't do much with them. So if you think male-female matters, that's your 1 dummy variable. That's the only one you can have. If you think whether they're in school or out of school matters, that's your 1 dummy variable. You can have 1 yes-no, 1 male-female, 1 dummy variable that's there. That's the maximum you can have. You need to avoid variables that measure the exact same thing. Don't say that I'm looking at the demand for microwave ovens and I'm including in it gasoline prices, and I'm also including in it fuel expenses that the family spends. Those 2 are the exact same thing. You just gave it a different name. So don't look at variables that are measuring the exact same thing. Unique independent variables. There has to be some literature tying at least one of your independents to the dependent. So somebody somewhere wrote an article. You can go to library.anderson.edu and you can search and you can find a gazillion articles that are there in all sorts of journals. Find one of them where they said, oh yeah, the weight of kids in school is based upon the amount of exercise they get. Okay, that's the one I'm going to use. So I'm going to tie that together. Find something that ties that together. Okay? The proposal has to be approved before you start. Don't do the research and then ask me if you can do it. The reason for that is because I don't want you wasting all your time. I don't want you looking stuff up and running regression and doing all that and then finding nothing. It would be nice and interesting if you find something that's valuable. So let's see if before you begin, what you're looking at makes sense. It'll make it easier for you. Okay? When we look at variable types, there are lots of different types of variables that exist, lots of different things. Some of these you don't want to use. Nominal is what we call dummy variables. So that's your yes, no, male, female, things like that. Those are called nominal variables. And if you look in a journal article, they're talking about nominal variables, they're just trying to be polite. They're not saying dummy variables. They're useful for identification, they're demographic type things, but they're not useful for much else. So try to avoid those if you can. Ordinal values are values that put things in rank order. but they have limited value. So if we ran a race, we're running a race, David came in first and Heather came in second, I would say David won, Heather 2, but that doesn't tell me that he came in 10 minutes before her or 10 seconds before her. So it's a kind of useful, but on the other hand, it's kind of not useful because I don't know that there's an even amount of range between each of those values. The person that came in third may have started the race and never even finished it. So that's a useful thing, but not necessarily the most useful. And again, this is just simply the same thing as I just said. These slides as well will be up on Canvas, so you'll have this information there as well. Okay? Interval data provides both an order and the size of difference. If we talk about people's weight, you know, a person weighing 180 pounds versus a person weighing 160 pounds, that's a difference of 20. A person weighing 160 and a person of 140, that's the exact same 20. I could put 20 pounds on a scale and it would be the same, whether we're talking about the difference between these two and these two, it's still the same. It's a difference in order, but it's the same equal distance for every one of those. Interval data is good data. Regression works well with interval data. If we're talking about income, and I say you earn $100,000 and you earn $50,000 and you earn $200,000, those are equal distances. Those are equal amounts. A dollar is a dollar is a dollar, whether we're between this range or this range. It's a nice equal number to work with. So counting the number of push-ups gives you a rank. Also lets you know that 2 push-ups is twice as many as 1. And there's value in that. Ratio is things like percentages. It's similar to interval, but I have a true 0. If you have 0% of something, you don't have any of it. So there's true 0 there. Okay? Force, time, distance, all those things have 0 points. If you ran 0 miles, you didn't go anywhere, you didn't do anything. These two are the best. Regression works really well with interval, works really well with ratios. Avoid using the first two if you can. Avoid it. Okay? So, here's my thought for the night. My thought is that in Indiana, there are 92 different counties. 92 counties, that's a good number to work with. Each one of those counties you can go through and you can find information about that county, including how much money the average person in that county makes. Well, that's the kind of data we're talking about because that's interval data. Somebody making $30,000 is only making half as much as someone making $60,000, and only a fourth as much as somebody making $120,000. So that's nice interval data to work with. You can go through and you can find data like that at all sorts of different sites. That data is collected. So the Census Bureau tells you how many people live in a county. That can be found from the Census Bureau. The Bureau of Labor Statistics tells you how much the average person makes in a county. You can go to different sites and find this data and put it together. Sadly, they don't do it each and every day. So like the Census Bureau only does it every 10 years. So what I have to do is I have to pick an equal time frame. Now it's 2016, but the last time they actually did the census was 2010. The last time they released the data was 2011. What I don't want to do is I don't want to say, here's income for 2015, and here's 2010 census numbers, and here's 2012 school numbers. So once you pick something, standardize on it. So what I'm going to do is I'm going to standardize on 2011's data for whatever values I'm going to use, and then collect that from the different sites. My theory is this. My theory is that within each of those 92 counties, the median household income, the average income, is influenced by these variables. I think that the percentage of population living in that county that have a bachelor's degree or more makes the average income go up. So I think there's a positive relationship that's there. I think that the percentage of people living in that county who are of working age makes it go up. You have a bunch of old people living there, well, they're taking retirement, so the income is down. You have a bunch of kids living there, and the income doesn't matter. So it has to be working age people, a percentage of people in the population that are of working age. That's a positive influence. I think that the average population per square mile matters. You go to Tipton County, there's 6,000 people in the whole county. They're all farmers, they don't have a whole lot of money. You go to Indianapolis, you've got things like Carmel and Fishers and places like that. You've got a lot of people living in a small area, you have higher incomes. So I believe that the average population per square mile, this will identify my urban areas versus my rural areas, and I think that's positive as well. Again, this is all theory. I don't know it, I believe it. I also believe the unemployment rate will matter, but in a negative way. Higher unemployment rate, lower median income. And the average number of housing units per square mile. Yes, population matters, yes, but if all those people are all living in one house, yeah, it's not because they're rich. They're living in one house because they can't afford to live elsewhere. So the number of housing units per square mile matters. You put a lot of housing units right on top of each other, they're probably cheaper, apartment type living. That's a negative. I'm counting that as a negative. There could be some overlap between these two. I don't think so, but I'm willing to accept the fact that there could be. But what I'll do is I'll run regression a couple times, see if it makes a difference if I put one in, take one out. So I'll take a look at that. Okay? That's my theory. Now the key is to simply go and define that data for the 2011 time frame, find it for that stuff. Here's some places that you can go to and find lots of different sets of data to work with. Almost every one of these you can go to and it will let you download the data in multiple formats. Choose to download it in Excel, save yourself the work, put it in there and work with it from there. That makes it a whole lot easier. The Bureau of Labor Statistics has a lot of stuff. They're also the ones that do the census. So you'll find census data and things like that all through Labor Statistics. Small area income and poverty estimates will give you information about the poverty level as the name implies and things like that. And you can find years, months, decades, all that stuff for you there. There is a fantastic site that Indiana University gets a grant to put up, and it's called Stats Indiana. It has so much stuff there that you better not come to me and say, I can't find any data to work with. And there's so much stuff there. Half of it's related to Indiana, the other half is just all over the place. They put links up for things all over, so you can find a lot of different things there. Go to those places, look at that data, download it, use it, play with it. You'll find stuff that you can find useful. Okay? So, in Canvas, you have my database for the night. If you want to bring it up and play with it as I go along with it, you're more than welcome to. Here's what I downloaded from multiple different sites, threw together, manipulated around, and came up with. This is the county ID assigned by the Bureau of Labor Statistics. So they assign 18,000 for Indiana, and then from there it's in alphabetic order. 18,001 for Allen, 18,003, for Adams, 18,003 for Allen, 18,005 for Bartholomew, so on and so forth. All 92 counties. Every county has a unique number associated with it. For our study, that means nothing. There's no difference between 18,001 and 18,003. The difference of 2 means nothing. So this column is here because it went with the data, and we can use it later if we need to go back and refer to particular counties. But from the regression standpoint, it means nothing. Here is the name of the county, so we can identify Allen County, Adams County, and so on. Here's the average income. This is our dependent variable. This is what we believe is affected by everything else. The unemployment rate, the percentage of the population that has a bachelor's degree or higher, the percentage of population between 25 and 64. Here's my 2 that I'm not sure about. Now, I had to do some tweaking to be able to get these numbers. You can't find that specifically. So what I had to do is I take a percentage of the housing units within the mile, do some calculations and such, and I came up with these 2 values. I'm not sure. I kind of coded them in yellow. I'm not sure if they're if one is measuring similar to the other. I'll play with that and see. And then here is the median age. We talked about how you don't want 2 variables measuring the same thing. Does this also fall beneath this? In my final regression, I don't want to have both this and this. Why? Because they're telling similar stories. So I put it here because I like it and I think it might matter, but I'm not really sure. But I don't want to run it at the same time. Okay? So I'm going to take what I have and go to my regression. When I go to regression right now, it won't be exactly what I'm looking for a couple of reasons. All right? Anybody see any red flags before I start? Well, what could be red flags?
So you need to and have to. They need value.
Okay, these don't have values. Regression is going to spit it out and say I can't go anywhere. Okay, so what I need to do is come up with some way of dealing with that. Well, one of the ways to deal with that is I really don't care about the state of Indiana anyway. If I'm looking at 92 counties, I don't look at 92 counties and the state. The state includes the 92 counties. So I need to take that out. So my regression can begin right here and go on down. The problem with that is Excel is not really smart, and I can't say begin from here and go on down and these are labels. I'd have to type the labels in by hand. And I don't want to do that. So what I'm going to do is I'm going to temporarily delete this column. Well, that's this row. I'm going to delete this row. And then that way I can keep the labels. I'm just going to be lazy. So let's take this out. Now.
You didn't get book. Okay.
What was that?
You got no.
Okay. So now I'm going to data, data analysis, choose regression. Okay. My dependent variable is going to be the estimated median household income. So that column. My independent variables, I'm not going to use median age because I do believe, like I said, that there is cross counting between them. Everything but that.
I'm sorry. What did you use as the Y?
For the Y, I use the median income. So in this case, it's column C.
Okay.
And then the independents are D through H. So I'm not using that last column. I am going to say labels, confidence level of 95%. It is not statistically significant if we don't do that. Constant is 0. 0 means 0, so it actually has a real value. We're going to say OK. And then we'll produce this worksheet. Before you click on anything, before you do anything, right click, choose to format the cells as numbers with 7 digits. The reason that I like 7 digits is because when you get to small numbers, what you'll see, and I don't have something showing here, but what you'll see is you'll start seeing the E showing. It'll say E and it'll say 10-3 and things like that. What it means is it doesn't mean that it's 10 to the third, it means it's 10 to the negative third, so you go out to very small numbers that are there. So just simply making it 7 digits solves about 90% of that. And I'm just going to switch this out a little bit, make the column a little bigger. And now I have this beautiful worksheet to work with. Okay. Now, as I look at this, the adjusted R-square is 98%. What does that tell me? What does that mean?
So really high
Really?
confidence.
Yeah.
Variables you picked over.
Means I should feel really good at this point. I ought to just take a break and walk around a little bit and brag, you know, because what I did by picking those variables is I identified 98% of the variation in the median income. The median county income. I didn't explain all of it. There's still something else that's there that I didn't catch. But I explained 98% of the difference in it. So I did a pretty good job there of picking variables. That's a good thing. So 98% is good. Here's 92 observations. That's what I want to, because I had 92 counties. If I didn't highlight something properly, you know, Excel doesn't tell you a whole lot. It's kind of goofy. If I had a 40 here, then it means, you know, I didn't get them all. So 92 is good. I want to check that. Adjusted R-square, I want to check that. I'm good there. You're going to say something.
It's all right.
That's okay.
Cause I mean, I was like, where you get 90? I'm saying 97. So you just.
The observations.
Yeah.
92 there. Yep, absolutely. Okay. Now, the error here, there's a standard error of 4,500. So what that's saying is, you know, there can be some stuff which is not accounted for. That's $4,500 in this case that it couldn't account for. Well, that makes sense. I mean, there's no way for regression to know that Hamilton County is just very rich. There's no way for it to know that. In this case, as I'm looking at income, and I do know there's a difference between Tipton and Hamilton County, I'm not going to worry about that. If that number was 100,000, it couldn't explain $100,000 of monthly income, that would be a problem. But here, I can live with that. That's not bad. Now, the next thing I want to look at is I want to look at my p-values. If the p-value is above 0.05, that variable is not statistically significant. It must be below 0.05. So I look at my first one and I say unemployment rate, 0.01. That is statistically significant. If it was 0.049999, it would be statistically significant. You don't look at it and say, well, it's 0.01, so it's really significant. No. If it's below 0.05, that's all that matters. So here, that is statistically significant. The percentage with a bachelor's degree, very significant. The percentage population, 25 to 64, yes. The number of housing units, yes. So far, we're looking pretty darn good here. Okay, and the population per square mile is below that as well. So every one of these is good. What is this really telling me? What this is really telling me is that if you want to compute what the income is, the average income per county, you have this formula here. The formula is that the median household income is equal to, that's not very clear. Median household income is equal to 0, that's our starting point, 0 plus negative 500.82 times the unemployment rate. Okay? Plus 499 times the percentage with bachelor's degree. Plus 821 times the working population. Minus 268 times the housing units. Plus 116 times population per mile. So this is our QD and QS and things like that. This is what it's telling us, is that you take the unemployment rate and you multiply it by a negative 500, and you're going to have to subtract that from whatever you get with everything else to get your monthly income. Does that make sense? If the unemployment rate is low, this would be a low number. So an unemployment rate in the county of 1% would mean I have to subtract 500 from what would otherwise be the monthly income. But if the unemployment rate is 10, I would have to subtract 5,000 from that. Does it make sense that the average income would be less if the unemployment rate was high? Yes. Yes, so that makes logical sense, and that graph that I had, that I was putting together, said that the unemployment rate, I expected to be a negative, and in fact it is. Does it make sense that the average percentage of the population with a bachelor's degree would matter? Sure. That the housing units on top of each other would be a negative, and so on and so forth. What I end up with is this really nice formula that you could then take and plug in any numbers. If the unemployment rate was 10%, this would be a negative 5,000. If the percentage with a bachelor's degree was, let's say 10%, that would be a positive 5,000. The working population was 30% of the people living in there. These cancel out. It would be $24,000. The housing units, we've got them right on top of each other. Well, let's say they're 10% of that. So we're going to subtract 26,000 for the negative 2,000, and then take the population they're living per square mile. We have 100 there. We end up with 9,600, and we end up with something like 50 County. So we don't have a whole lot of people living in a square mile. We don't have a whole lot of housing units. We've got 30%, 1/3 of the people who are working, 10% of them with a bachelor's degree. We end up with something very small. Hamilton County, we would have a whole lot bigger numbers there, smaller numbers here. We end up with something pretty significant. You can take Excel now, and you can take that formula that you have, and you can plug in those real numbers for those counties, and you're going to get really, really close. Really close. Now, to be overly, I don't know what to say, overly concerned, whatever, I want to see if the median age works better than this. So I'll just simply take out this column, run it again. Let's put the median age in there. Run the exact same thing, change nothing. 7 digits. I can see that really I didn't really gain anything. I still have 97% here. It's a little bit less than it was, but that's a very small increment. So the adjusted R-square didn't change a whole lot. Here my unemployment rate changed. So the value that was there, which was a negative 500 to begin with, is now negative 381. The 579 replaces the 499. And you can see that every one of these things changed. So they all changed. Median age does still turn out to be significant, but it has a pretty high value with it. The average age is 35. 35 times 1,000. 35,000 becomes the average median income plus adding these things in. So they both can be used. Either one of them can be used. We'll do it one more time and use both. I should get an error. Let's see. Let's move this over. Don't like empty spaces. Let's go to I. Now, what happened? What changed? Now I'm including both the median age and the percentage of population between 25 and 64. What happened? What happened? What is it?
Median age is insignificant.
Yeah. Now median age, which just a moment ago on the other spreadsheet was significant, now it's not. it has a p-value greater than 0.05. So what that's telling me is, you know what, you gotta rerun it without that. It's above 0.05, take it out, run it again, you'll get better results, which is what I knew, which is what I suspected would be the case, and that is indeed the case. So, yeah, that's a lazy way of finding that two of them are measuring the same thing. You should know it intuitively before you depend on that. But it's going to tell you. I mean, you're going to find it that way. Okay. Questions about that? Regression's cool. I mean, it really is. It's a nerdy tool, but it's really cool because it lets you find those relationships that are there. It intuitively makes sense that the income per county would be a factor of whether people in the county are unemployed or not. It makes sense that it would be a factor of whether people in the county have a bachelor's degree or not. Intuitively that makes sense. What's cool here is that numerically you can show that it makes sense. Numerically now I can quantitatively say, here's the formula for coming up with that. That's what's cool about it. Okay. Each week we'll run through a little something. As we're doing so, as we're going along, I want you thinking about what you're going to do. So don't wait till the very end and say, hey, I have a proposal. Here's my idea. You look for patterns that are there. Look for things that are there that you think this could be caused by that. One of the biggest challenges you'll have is figuring out what you believe and can also find data on. Yeah, there's an awful lot of data sets that are there, but sometimes they're not the data sets that you're looking for. So make sure it is a data set that you can find and that you can use. I will discourage you, is a good word. I will discourage you from using data sets that you have to create yourself. So you may have this really great idea that at your employer, they do this and they do this and they do this. This is really cool. And that may indeed be the case, but unfortunately we only have so many weeks. And by the time you get permission to collect that data and to put it together and things like that, you're setting yourself up. So try to avoid collecting data. Try to, if possible, use data that already exists. Okay. All right, any other questions about the regression? Okay, we're going to stop with that then. Here's